Hi guys, welcome ulit sa YouTube channel natin. Ito na yung first topic natin sa steel design. Now, before tayo mag-solve ng mga problems, mag-discuss sa tension members, yung mga columns, at yung beams, counting introduction lang muna sa steel design. Now, I'll try to focus sa mga important parts lang, okay? So, anyway, yung gusto ko is matutunan nyo yung ano yung may chance man na lalabas sa board exam. So, yung mga theory behind nito, actually, I'll try to skip if ever feel ko na hindi naman siguro lalabas. Okay, but time to time, of course, lalagyan ko ng concept yung mga formulas, of course, kasi para alam din natin kung kailan natin gagamitin. Okay. So, proceed tayo sa design philosophies agad. So, we have, actually, dalawa lang to. By the way, again, ang basehan ko actually is itong NSCP 2015, ASD and LRFD. So, sa design philosophies, meron tayong ASD at saka yung LRFD. So, ang ASD is ang member daw is selected based on the either area or moment of inertia that are large enough to prevent the maximum load from exceeding an allowable value. Now, I think almost all design philosophies naman ng importante yan na dapat, anong tawag doon, meron kang load, okay, or meron kang required load, tapos meron kang capacity sa member mo. Dapat, obvious naman, no, dapat na ang required load mo, dapat mas maliit pa sa, okay, capacity ng member mo. Bakit? Pag mas malaki pa siya, okay, mag-fail na yan, okay, ang member mo. Okay, anyway, dito sa ASD, maximum load versus allowable value yung tinatawag dito. Na ang maximum load, by the way, dito is actually working loads lang, meaning wala tayong factor na mangyayari. Okay? Unlike sa reinforced concrete, naalala nyo yung reinforced concrete natin sa board exam, di ba? Meron tayong factor, 1.2 at saka 1.6 para sa dead load. Para sa, dead load at live load respectively. Okay? Now, plastic design naman, dito sa plastic design, medyo malaki-laki na yung load natin dito. Okay, bakit? This is actually based on consideration of failure conditions rather than the working load conditions. Okay? Now, a member daw is selected based on the criterion that the structure will fail at a load substantially higher than the working or service loads. Meaning, this time sa plastic design, yung loads natin actually mas palalakihan pa natin. Okay? So this time, yung loads natin dito meron ng mga factors. Okay? Now, ang LRFD naman, sa LRFD, same pa din, meron kang load, meron kang capacity. Now, ang LRFD, yun nga, gagamitin natin yung concept counting sa plastic design kasi yung load sa LRFD, okay, we will factor those loads. Tapos, yung capacity niya, kailangan pa din natin i-factor din. Okay? So, in addition daw, the theoretical strength of the member is reduced by the application of a resistance factor. Kaya tawag dito is load kasi meron siyang load factor, meron din siyang resistance factor. Okay? Now, sa allowable strength, wala kang factor sa load. Okay, but sa resistance niya, okay, sa nominal strength sa ASD, meron tayong tinatawag na factor of safety. Later on, papakita natin. Okay. Next slide. So, kung tingnan nyo, if ever meron kayong hard copy sa NSCP 2015. So, sa NSCP 2015, actually, Chapter 5 yung steel design. So, sa Section 502.3.3, nandun yung design for strength using load and resistance factor design. Okay? So, design shall be performed in accordance with this equation 502.3-1. So, RU must be less than or equal to the factor, okay, resistance factor times nominal strength Rn. Now, ang RU dyan is yan na yung load mo. Ultimate load na yan. Okay? Actually, ultimate load na yan. Meaning, tingnan nyo, required strength using LRFD load combinations. Next slide, papakita ko sa inyo yung load combinations. Rn naman is nominal strength. Okay? Yung itong symbol na to is actually, ang tawag dito, phi ata to. This is actually the resistance factor. Tapos yung PRN, this is the design strength. Okay? So, pag LRFD take note, please take note. Tawag natin dito is the ultimate load. Okay? Ito naman, this is the design strength. Okay? Yung capacity na is the design strength. Bakit? Kasi sa ASD, iba kasi yung tawag sa capacity natin. Okay? Anyway, dito, tingnan natin. Ito yung load combination sa LRFD. Nasa NSCP 2015 yan. 2.3.1. Itong load combination na to actually sa internet ko lang ito kinuha kasi wala akong clear copy sa NSCP, kasi nga hard copy lang yung meron ako. But, more or less similar lang ito sa nasa book natin. I mean, nasa NSCP 2015. Now, we will try to focus dito sa combination 1 at saka combination 2, yung 1.4 dead load at saka 1.2 plus 1.6, ayan, dead load plus 1.6 live load. Okay, now, by the way, kung saan yung pinakamalaking load dyan, actually, yan yung gagamitin natin as yung, yan, yung RU na yan. Okay, yan yung critical load natin. Okay, yan yung load na i-design natin. Okay, so proceed tayo sa ASD. Now, sa ASD, the design for strength using allowable strength design, nakita yon RA, same pa din, meron kang load, meron kang capacity. Now, ang load mo is actually R sub A. So, ito yung required strength using ASD load combinations. Now, pag ASD, again, ulitin ko, working loads, walang factor, add mo agad. Okay, dead load plus live load agad, wala nang factor. Okay? But notice yung capacity natin, ang tawag natin sa capacity is actually allowable strength design. I mean, allowable strength. Okay? So, sir, bakit may RN? Same lang ba sila ng RN doon sa LRFD? Yes. Actually, yung nominal strength, ang pag-solve ng nominal strength natin, actually the same lang for LRFD at saka ASD. Magkakaiba lang sila sa pagkuha natin sa capacity. Okay? Yung capacity kasi sa ASD, allowable strength yan. Okay? Factor of safety yung gagamitin. While ang capacity naman sa LRFD, design strength yan. Okay? Resistance factor yung gagamitin. Okay? So, I hope okay tayo dyan. By the way, ito yung load and combinations for ASD. Nandun sa NSCP 2015. So, ito yung chapter niya. I mean, ito yung section niya, 203.4.1. I-check nyo if ever meron kayong hard copy. Okay? Now, yan lang muna para sa introduction. Tapos, by the way, before tayo mag-proceed sa mga next topic, importante na alam nyo, meron kayong counting idea, but I think alam nyo naman siguro, kung ano yung mga standard cross-sectional shapes, yung mga properties, okay? So, by the way, ito yung mga standard cross-sectional shapes natin. We have yung W section or yung I-beam natin. Meron tayong channel. I'm sure familiar kayo nito. Itong S-beam, okay? Meron tayong T-beam. Itong Z. By the way, yung Z is lumabas, mayroong lumabas na Z purlin sa previous na board exam. Okay, so meron tayong ano yan, unequal angle at saka yung equal leg na angle. Now, importante na alam nyo kung ano yung mga notations sa properties nito. Kasi later on, sa mga problem solving natin, importante na alam nyo paano hanapin yung mga properties using our Excel file, okay? Now, for example, W shape, okay? So, ito yung mga pangalan na, halimbawa, W shape. So, American wide flange, I or H shape, steel beams are referred to as W shapes and are designated by the letter W followed by the nominal depth. So, ito yung nominal depth, okay? In millimeters, at saka yung mass naman niya in kilogram per meter. Okay, now in this slide, actually, this is, SI yung units dito. Okay. For example, meron tayong W410 by 85. Ibig sabihin lang yan, actually, is, yung 410, ito yung nominal depth, okay, ng section natin. Tapos yung 85 stands for its mass, okay, per meter. So, that's 85 kilogram per meter. Later on, pag nag-design tayo ng mga section, so yung mga mas economical, obviously, yung mas magaan na mga sections. Okay. The shapes consist, okay, walang problema dyan. Now, notice na meron tayong mga notations or mga symbols para sa properties ng section. Halimbawa, D is the deep of the beam, depth of the beam yan. So, BF, width of the flange, TF, thickness of the flange, TW is the thickness of the web. Again, importante na alam nyo to, okay? Yung mga symbols dyan. Kasi later on, sa mga problems, minsan, mga symbols ang lalagay, okay? Wala na yung mga general term na yan. Yung width of the flange, yan, wala na yan. Symbols na lang ang ibibigay. Now, gusto ko i-download din nyo to, itong Excel file. Okay? Itong Excel file na to, this is actually, nakuha ko to sa AISC na website. Link, don't worry, ipopost ko yung link sa description. So, this is I think free lang to kasi nasa website man nila. So, AISC, Shape Database version 15. Okay, so, ito yon if ever hindi pa kayo familiar sa mga, yung mga terms dito. Okay, try to practice, tingnan nyo to kasi kailangan natin to later on sa mga videos natin. Okay, tingnan nyo, slenderness ratio, BF over 2TF, mga ganyan. Okay, plastic section modulus. So, sa next sheet niya, yan. So, ito na yun. Ito na yung database. So, meron tayong W section. Lahat, I think, nandito naman lahat, no? W section. I think channel yung sunod. Angle pala. Okay. So, I hope magamit natin to. Don't worry, sa tutorial natin, I'll see to it na magamit natin to. Okay, yung mga properties ng iba't ibang section. So, don't worry, upload, ano tawag dun, ilalagay ko din to. Ilalagay ko yung link ng AISC para ma-download niyo to. Okay? So, yan lang muna para sa introduction. Next topic natin is actually, proceed na tayo sa next topic, yung tension members. So, I hope i-download niyo to before kayo manood sa next video. Okay? Salamat sa panonood.